तमाम लिविंग थिंग्स में पॉलीमर्स होते हैं. Polymers are the macromolecules. When I say the word polymer, poly means many, ठीक है, and mer means unit. It means that it is something which is made up of many smaller units joined together. इस प्रोसेस के लिए हम लार्ज ऑर्गेनिक मैक्रोमोलिक्यूल्स को एग्जांपल्स के तौर पे कोट करते हैं. ये बहुत सारे स्मॉल रिपीटिंग यूनिट्स से बने होते हैं. इन रिपीटिंग यूनिट्स को हम मोनोमर्स कहते हैं. The word mono means one, the word mer means unit, यानी one unit हमारे पास होता है और उसको अगर हम रिपीट करें एक नंबर में, वो नंबर 100 से लेकर मिलियंस तक हो सकते हैं, तो हमारे पास पॉलीमर्स बन जाते हैं. ऐसे को हम होमोपॉलीमर्स कहते हैं. होमो means same and polymer means that is made out of same repeating unit. ठीक है. इसमें पॉलीथीन, पॉलीप्रोपीन, पॉलीक्लोरोथीन इसकी बहुत अच्छी एग्जांपल्स हैं. इसकी एग्जांपल को एक्सप्लेन करने के लिए इन्होंने यहाँ एक बहुत अच्छी डायग्राम बनाई हुई है कि हमारे पास समटाइम्स नेकलेसेस आर मेड आउट ऑफ अ सिमिलर बीड connected to one another in a big chain or with the help of a thread. ठीक है. So it's a very good example. एक सिंगल बीट को आप एक मोनोमर कहेंगे, ठीक है, यानी सिंगल रिपीटिंग यूनिट, और इस पूरे नेकलेस को फिर आप पॉलीमर कहेंगे. ठीक है. Means the macromolecule, the bigger, larger structure which was made when these repeating units were combined together. और इस प्रोसेस को जो इन दोनों को आपस में कन्वर्ट करता है उसे हम फिर लेटर ऑन पॉलीमराइजेशन कहते हैं. ठीक. तो यूं हमारे पास पॉलीमराइजेशन की फिर फर्दर दो टाइप्स आती हैं, addition or condensation. One type is addition, which you can see in front of you. Second type में हम later on पढ़ेंगे, वो condensation है, वो इससे slightly different होगी. उसमें ये single repeating units नहीं हुआ करेंगे. इसी तरह फिर polymer की भी हमारे पास दो types आती हैं. एक homopolymer, ठीक है. Homo means same. Homopolymer example यही necklace है, which is made up of a single repeating unit combined together. और then later on हम copolymer पढ़ेंगे, ठीक है, जो कि condensation से बना होगा. So actually addition polymerization results in homopolymers, जिसकी example हमारे सामने ये necklace है. Later on जब हम condensation polymerization second type पढ़ेंगे तो फिर उससे copolymers बनाएंगे, which are going to be little bit different from what we have just studied. ठीक है. So we are going to start with addition polymerization for now. Addition polymerization rather बहुत easy है. The word addition actually comes from the addition reactions of alkenes. Alkenes की खास बात ये होती थी कि उसके अंदर double bond exist किया करता था. और addition reactions में double bond break open होता था, single bond में convert हो जाता था, और जो भी हम इसके अंदर molecule add करना चाह रहे थे, वो दोनों carbon atoms पे add up हो जाता था. यहाँ इससे मिलता जुलता ही काम होता है. डबल बॉन्ड ब्रेक ओपन होता है, कन्वर्ट हो जाता है सिंगल बॉन्ड में, और एक्चुअली यही मॉलिक्यूल्स हम आपस में कनेक्ट कर देते हैं, which makes a large long chain of a macromolecular structure. ये आपके सामने ईथीन है. हम हाई प्रेशर हाई टेम्परेचर कैटलिस्ट की प्रेजेंस में all of this can be summarized by simply writing polymerization on the top of reaction, which literally means the same thing, that we have used some temperature, some pressure, and a catalyst to convert this monomer into a polymer. And right now, the name of this polymer is polyethene. Okay. So double bond को break open कर दें single bond में, then both of these carbon atoms would be capable of making one bond more. So इस carbon से पहले एक line लगाएं, उसे intersect करते हैं हम ब्रैकेट से. इस कार्बन के साथ भी हम एक सिंगल बॉन्ड लाइन लगाते हैं, उसे भी इंटरसेक्ट करते हैं. दिस इज अ कन्वेंशन टू शो continuation. This is known as continuation. And continuation has one separate mark when you are making this structure. जब भी आप पॉलीमर का स्ट्रक्चर बनाएंगे, continuation जरूर शो करेंगे. This continuation tells us that this structure has been repeated a number of times, and n is the number that we usually write at the bottom, and this is usually a very large number. We have already talked about it. This can be from 100 to more than 1 million or any bigger numbers than that, right? तो आपके पास double bond break open हुआ single bond में, इसी structure को हम आगे पीछे connect करते जाएंगे, so we show continuation that the same molecules are connected at the back of this one and at the front end of this one. So continuation is shown with single bond signs intersected by brackets, writing N at the bottom of the polymer and N at the start of the monomer. This is known as balancing. ये conditions हैं reaction की, ये balancing है reaction के लिए, ये correct structure of monomer है, ये correct structure of polymer है, including continuation. Monomer का जो कोई भी नाम होगा, the nomenclature is very easy. हम उससे पहले सिर्फ poly लिखते हैं. Without a change, ये polymer का नाम बन जाएगा. Addition polymerization में naming बहुत आसान consider की जाती है, क्योंकि लफ्ज poly add होते ही polymer का नाम बन जाता है. I guess that's the easiest of stuff. Okay, so let's go with a few more examples. I'm going to stop sharing the book. I'm going to share the whiteboard screen. We're going to try a few examples. Not just ethene, we can go with other molecules such as propene. Okay, if we look at propene, propene is something like this: CH3, CH, double bond CH2. लेकिन इस स्ट्रक्चर को हमने हमेशा इस तरह से लिखना होगा कि हम इसे मोनोमर शेप को दे सकें. For that purpose, we'll always write carbon-carbon double bond in the center. ये carbon-carbon double bond हमने यहाँ पर लिख दिया. अब नोटिस करें, डबल बॉन्ड के इस तरफ जो कार्बन है उसके ऊपर एक हाइड्रोजन है और एक मिथाइल ग्रुप है. So let's write them at diagonals. ये हाइड्रोजन हो गया, ये मिथाइल ग्रुप हो गया. इस कार्बन के ऊपर सिर्फ दो हाइड्रोजन है. So a hydrogen diagonally over here and a hydrogen diagonally over here. This is the monomer. Let's consider there are n number of monomers and n is a very large number with proper reaction conditions, which I'm not going to write heat, pressure and catalyst every time. Instead, I'm going to write a single word, polymerization, which depicts itself that there was some heat, there was some catalyst, there was some pressure, and we successfully converted our monomer into a polymer. Polymer के लिए क्या करना है? Instead of a double bond, single bond लिखें. इनको straight up show कर दें diagonals की बजाय. ठीक है? Exactly इनकी positions वैसे की वैसी ही रहेंगी. हम इनमें कोई change नहीं करेंगे. ठीक है? ऐसे double bond, single bond में convert हुआ तो further bond की गुंजाइश बच गई. उसको हमने bond की sides पे show किया. Intersecting lines बनाई. बाकायदा ब्रैकेट्स के साथ n को बॉटम पे शो किया and there you go, you're done. So if this is propene, according to the naming rules, this must be polypropene, and that's how we write it. Now in exams you might be given with the structure of the monomer and you're supposed to draw the polymer structure along with continuation, balancing, all that kind of stuff, whatever they ask for. ठीक है, तो इस तरह से आपको ड्रॉ करना होता है. However, IGCSE examiners sometimes manipulate this question by asking you to draw 2 or 3 repeat units. अगर आपको वो कहते हैं तो उसका मतलब है उतने repeat units draw करने होंगे. ये एक repeat unit है. Let's say if they ask for 2 repeat units, it's pretty easy. आप इस तरह का एक repeat unit बनाएंगे. Let's see. This is a single repeat unit. अगर वो आपको 2 repeat units कहते हैं, ऐसा एक और ड्रॉ कर दें इसके साथ. You can either draw it on the left of it or the right of it. It doesn't matter, but it has to be in the same symmetry. आप नोटिस करें जहां पर methyl group था वहीं पर methyl group है और बाकी सारी symmetry वैसी है. इसे कहते हैं हम 2 repeat units. Still, इसमें भी आप अपनी intersecting brackets और n वैसे का वैसा शो करें. These are 2 repeat units. They may ask you to draw 2, they may ask you to draw 3 repeat units. It's not a problem. आप उतना से extended के draw कर दें. So read the question carefully. वो आपको name कहता है, structure कहता है, single repeat unit, double repeat unit, triple repeat unit के साथ उसे उसी तरह से वो structure draw कर दें. This is usually a 2 to 3 mark question. और जो कुछ इसने कहा हुआ है अगर आप वो सारा कुछ बनाएंगे, you'll get all the marks that have been stated for that specific question. Are we clear?
Yes, sir.
Okay. Can you annotate so we can try more questions? Or should I do them if you're not able to annotate?
Yeah, I can annotate.
Okay, good. Let's try next one then. This time you are going to go with a different structure. We are going to try chloroethene. And the structure of chloroethene is something like this. So I've drawn the monomer. You're supposed to draw the polymer, balance out the equation, a proper structure with continuation, and you're also supposed to write the name for it. Go ahead.
Okay, sir.
Very good. How about the name? Right, polychloroethene. Let me tell you the common name. The common name usually written with it is vinyl chloride. So the name of the polymer commonly used is polyvinyl chloride. And this is what you're going to see in your book, that it has been used by the name of polyvinyl chloride, abbreviated as PVC. And with this abbreviation PVC, keep that in mind. We're going to discuss a few usage along with this name. Let's continue. This time I'm going to change the question a little bit. This time I'm going to draw the polymer for you, and you are going to draw the structure of monomer for me. And this time I'm going to go with different atoms attached on carbon, not just hydrogen or methyl or chlorine, which you have been used to by now by different examples. So there you go with the structure. You can start solving and drawing the monomer. Let
The
me give
name
you,
would be tetrafluoroethene.
yeah, you're right with the name, but there is a small problem with the structure. Monomers do not have continuation.
Oh,
You have
yes,
actually
sir.
drawn 5 bonds of each carbon atom. Yeah, now you're correct. So yes, very good. Name would be tetrafluoroethene, and that's why the name of the polymer is polytetrafluoroethene. We have shortened it up as PTFE. The common name is Teflon. Keep this common name Teflon or PTFE in mind, and we're going to discuss a few usages with this name. Moving on, let's go with the last example. And again, I'm going to draw the structure of the polymer, and you're supposed to draw the structure of monomer. This time, let's use bigger number of carbon atoms, since we have been using only 4 to 5 carbon atoms so far. can go ahead and draw. And the name would be
Styrene.
styrene, right? As the name of the polymer is polystyrene, so the name of the monomer is just styrene. Polystyrene is abbreviated as PS, and along with the rest of the usages of the previous polymers, we are going to also check out the usages of polystyrene. So I'm going to save all of these, and I'm going to get back to the book. So when we talk about the book, we have all of these examples also illustrated on the book, just for a fact that polystyrene's example is missing as a part of the structures. You would see ethene की example यहाँ पे पूरी clarify की हुई है, फिर propene की example आप देखते हैं, fluoroethene या vinyl chloride example है, then we have tetrafluoroethene over here, but you won't see any example of styrene over here. However, as table 1.2 tells us, all 5 of these examples are given over here with their polymer and their trade names, abbreviations, monomers and their structures. यहाँ पर आपको polystyrene या phenylethyne मिल जाएगा. यहाँ पर properties भी हैं. Polyethylene is tough and durable, and that's why used for plastic bags, bows, bottles, and packaging. Polypropylene भी tough और durable है. ये crates, boxes और plastic ropes के लिए use होता है. Polychloroethene, or which we abbreviated as PVC, is strong, hard, but it's not as flexible as polyethylene, so we use it for insulation, pipes, guttering, and sanitation purposes. Polytetrafluoroethene, जिसे हमने Teflon or PTFE के तौर पे abbreviate किया था, this is used in non-stick surfaces because it can withstand a very high temperature. इसे non-stick frying pans में, taps में और joints में use करते हैं. ठीक है. Polyphenylethene या polystyrene PS के तौर पे जिसे हमने abbreviate किया था, ये light होता है, poor conductor of heat होता है, तो हम इसे insulation या packaging foam के तौर पे use करते हैं. This table is pretty important and we usually ask our students कि आपको ये table अच्छी तरह से याद होना चाहिए. Coming to concluding addition polymers की खास बात ये कि सारे polymers long chain molecules होते हैं जो large number of monomer molecules से बने होते हैं. Addition polymers involve करते हैं कि monomer के अंदर कम से कम कार्बन-कार्बन डबल बॉन्ड जरूर हो ताकि उसे ब्रेक ओपन करके आप इन्हें आपस में कनेक्ट कर सकें. Addition polymers homopolymers होते हैं. ये सिंगल मोनोमर से फॉर्म होते हैं. During addition, डबल बॉन्ड ब्रेक ओपन होता है, मॉलिक्यूल्स आपस में एक दूसरे के साथ ज्वाइन करते हैं, लिहाजा हमारे पास एक बहुत बड़ा पॉलीमर एक मैक्रोमोलेक्यूल के तौर पे बहुत लॉन्ग चेन की सूरत में रिसीव होता है. Some examples are shown in the diagram, figure 11.16 over here for polypropylene, polychloroethene, PVC, which is, and polytetrafluoroethene, PTFE or Teflon. So, ball and stick model से आपको बड़ी अच्छी तरह idea आ जाता है कि how long and what kind of chains would that be. यहाँ पर हमारे पास addition polymerization complete हो जाता है.